Hello, welcome and a very good evening. And tonight we are looking at this thing. I hope you can make it out. This is the RGB to HDMI, a tiny little device that clips onto a Raspberry Pi Zero, which you can see the ports of here basically. And it comes with an extra buffer board to attach a 9-pin sub-D connector. Which was used on many vintage graphics cards, such as this Hercules clone card. It outputs monochrome TTL level signals, but we also have the CGA Redux card later, which we assembled in a live stream or a couple of live streams a while back. That also speaks the same protocol, basically TTL level, RGB and intensity. You can also attach EGA cards to this. You can't use it with VGA or the Amiga, at least not directly. For that you would need a little bit different wiring inside of the box, but I bought this especially for all the TTL devices that I have. You can also use it with the Acorn machines, the older ones like the Electron or the BBC Micro. They also speak TTL level RGB, or the Commodore C128, which has a CGA style connector basically. You can also use that with that. And I already have an OSSC scanline converter, which converts, for example, from VGA to HDMI, but it can't do the TTL signals very well. So that's where this comes in. And yeah, we want to check out how it works. Also test a bunch of these old Hercules cards. This is not mine, this is from another forum user. He sent that to me for testing because he also doesn't have a monitor to test this with. So I'm using this, and we'll also use the CGA card and see how this thing fares and what it can do. Problem is you have to supply your own Raspberry Pi, which are a bit rare nowadays, but this will hopefully get better in the coming months during this year. But at the moment it can be quite hard to get one of the zeros. It supports both the regular 01 basically, but also the 02, which supports, I think, higher sampling rates, etc., because it has a more powerful CPU. This year is the 02, so hopefully we'll get all the bells and whistles. So yeah, let's put this thing together and see what it can do. So here we have the setup. I took out one of my old 286 boards because it has an 8-bit slot, because these full-length cards do not fit into the 16-bit sockets because this part is in the way and they go all the way to the bottom. So this is currently my only working board with an 8-bit slot that can fit these things. Yeah, but the Hercules card is in. We have a hard disk controller and floppy controller, so we have everything set up so we can run a few things. And let's take a look at the monitor if it actually works. And it does. The picture is actually super sharp here on my very old Philips LCD screen. That is only DVI input, but I have a DVI to HDMI cable, but the Pi is heavily running with this. So the picture quality is really, really good. The machine currently hangs because it tries to load EMM386 and fails. I will set it up in a second so that we can test a few things. So we got Windows running now on one of my Hercules cards, and you can see the flicker. This is actually normal in the beginning. You have to go into the on-screen menu, and there is the auto-calibrate video sampling option. You have to confirm twice, and then it's running some kind of auto alignment for the sampling, because while it's a digital signal, it's still with a lot of jitter, and a CRT doesn't care about that, but if you want to sample it, it's a bit of a problem. And now it says press menu to save configuration or press up or down to skip saving. For example, if the auto calibration didn't work, but here it's fine. It also has shown us some of the parameters. Sampling phase is 2, half pixel shift 0, clock multiplier is 6, pixel H offset is 3. I think you can still adjust that. In DOS I noticed that I have a little bit of the left screen cut off after calibration, so I might need to tweak that. No errors, which is fine, and it's sampling in 6 bits per pixel, which is also fine. This DAC on here, or ADC, does up to 12 bits per pixel, which is great, and which is probably sufficient for the Amiga, but here we don't need that much, obviously. So we saved, then we're going up to the return and exit, and yeah, so now we have a very, very brilliantly, very sharp Hercules graphics mode thingy for Windows, actually. Yeah, looks fantastic, I would say. Next up we have the CGA Redux card, which is the homebrew version of the color graphics adapter. And let's see what it looks like on the RGB to HDMI. And I must say it looks very sharp indeed. The colors are great. It is really, really, really crisp. I must say this seems to work really well with this stuff. We'll run Area 5150 for a little bit to check what it does with the weird modes that you can tweak out of the CGA card. For anyone who doesn't know, the Area 5150 demo was presented last year, and it uses quite neat tricks on the CGA card, like this here, which haven't ever been done before. It has been programmed by a few of the best demo scene coders, I would say, for the Retro PCs. And it tricks the CGA into displaying high-resolution graphics with 16 colors, where before you could only do like 320 by 204 colors. Now you can do 16 colors with 640 by 200, which is quite impressive. And the demo works mostly up to a certain point, because the later parts are really timing dependent and they need to run on an original PC or XT with 4.77 megahertz. So on my 286, it hangs after, I think, 2/3 of the demo or half of the demo, I'm not sure. But it doesn't matter. At least a few things we can watch here. And yeah, the RGB to HDMI actually handles these heavily tweaked modes and complicated modes extremely well. And remember, this is basically a graphics card from 1981, where IBM probably never thought that anything like this could be possible on the CGA. And that is something, really. For example, this here, this is 640 by 216 colors, and that doesn't even fit into the RAM of the CGA card. So I guess they are swapping in and out stuff as they go from scanline to scanline. Or this effect here, that's clearly amazing work in reprogramming the CRTC controller. Yeah, I'll let you watch a little bit here, and then we'll check out the next thing. And now we'll be taking a look at this ATI EGA Wonder, which is a very late EGA card. It has the 9-pin connector, and there is a spot for a VGA style connector, and this thing could do 800 by 600 if I remember correctly. But we will use it as a proper EGA card, and as you can see, it doesn't have the analog output here, so that doesn't help us. Let's fire this thing up and check it. And it's no surprise, the EGA mode also works pretty nicely. There's actually a special profile for the ATI Wonder 800 Plus that we are using here. And I switched to that for this, but this also works mostly with the regular EGA profile and even with the CGA profile, as this low-res 320 by 216 color mode is actually compatible with CGA monitors. Not necessarily with the CGA card itself, because it has not enough RAM to normally display this mode, except using the tricks that we saw in the Area 5150. But yeah, it definitely is doable on CGA style monitors. There's a difference between full-scale EGA monitors and CGA monitors. The EGA monitors also have support for 350 lines that we will have a look in a short while. And CGA monitors can only do 200 lines with 15 kilohertz. Yeah, but as you can see, image is sharp and crisp, and colors are very nicely saturated. So I would say this works really well. So here we have the PC EGA chosen. However, when I was in text mode in the BIOS, this would not work. There are multiple settings. PC CGA would even work because it's the same output basically. But you can also switch to PC EGA Wonder 800 Plus. And since this is the EGA Wonder 800 Plus, I think you should use this for this card. And then it also works perfectly fine in text mode. So I think it depends on which mode you're currently in. But it's best to choose the card that most closely matches the one that you have actually installed in your system, and I guess that makes sense. For the EGA Wonder, I didn't even have to go to the auto calibration for the sampling, because here I don't see any jitter or anything, so that's perfectly fine. So now I've started Robot Junior, which is a game that runs in EGA high-res 640 by 350 mode. And the auto detect just goes to EGA mode 1, which is not quite correct. However, if I go to EGA mode 2, which should be the high-res mode, it looks okay at first, but at the bottom down here there's something missing, which you can't properly see right now, but there should be some bit of the walls that you can also see at the top of the game. So that is not good. Also, if I go out of the menu, which I will do only very briefly, the image starts to flicker. So I can't get the high-res mode of the EGA cards to properly work. I even tried to go to PC EGA and then down here also to the EGA mode 2, if that's possible, but it looks quite similar. It also additionally has a jitter around the pixels, which doesn't even go away with auto detect. EGA mode 240, so that's 80 versus 40 columns, I guess. It's very similar, albeit the flicker looks a bit different. So that definitely doesn't work. So at the moment I can't make high-res games, and probably Windows either, to work on the EGA card. This is not super important to me right now, because there are very few games that use this mode, but it might be something to consider if you are looking for a way to play high-res EGA games or use Windows on an EGA high-res monitor, basically using this thing. Yeah, I might try a little bit more, but so far I couldn't make it work. I'm actually wondering why it's fine in the menu but then loses sync or something when I leave the menu, or if this is an issue with my Philips monitor. That could be the problem as well, but I don't have anything to test with otherwise. So that's all I wanted to show you for the RGB to HDMI converter with the TTL converter board. There are more boards available that plug into this for the Amiga, for VGA, etc, etc. Or you can make your own wires. This here has a special buffer chip to protect the board itself, etc. But you don't technically need that, but it's recommended. Yeah, and I think it's a great product. You can have it for like about 50 euros plus the Raspberry Pi, which is 20 to 30 euros if you can get your hands on it, actually, because at the moment they are pretty hard to come by. The only problems that I encountered were with the EGA Wonder in high-res modes. So your mileage may vary, maybe other EGA cards work better, maybe future firmware upgrades will fix that. It's an ongoing project and you can already choose from dozens of different computers and video standards. So that's a very nice thing. And my OSSC deals with all the analog inputs and this one deals with the digital inputs, which is a nice thing. Getting one of these conversion boxes, which are low latency, high quality, is never cheap. So 70 euros at the least for this one. The OSSC is by now much more expensive. I think they're going now for 200 euros. Back when I bought it was like half of that. But that's due to the chip shortages. Everything becomes more expensive and inflation and all the stuff. So whatever you're choosing, I think this product is actually pretty neat and works pretty well with the Hercules card, CGA and EGA low res. Other things, your mileage may vary. But that's it for today. If you want to support me, head over to Patreon, or if you want to do a one-time donation, you can go to Ko-Fi or to PayPal, or you can also do YouTube memberships, which are all linked down in the video description. If you don't want or can do that, just leave a thumbs up, a thumbs down, leave a comment, tell us how your setup looks like. And other than that, and that's it for today. And I hope to see you in the next video. So long and bye.